Welcome everyone for this VLSI design lecture series. In today's video lecture, let us discuss about stick diagrams. Let us try to implement stick diagram of NAND gate. In the previous video lecture of stick diagram series, we had seen how to represent a PMOS transistor and NMOS transistor using stick diagram, and using that basic, how can we represent a basic CMOS inverter using stick diagram? That was seen in our previous lecture series with respect to stick diagram. In today's lecture series, let us try to represent stick diagram of NAND gate. So this is how the circuit diagram of NAND gate is represented. As I told you, for PMOS transistor is represented as pull-up network and NMOS transistor is represented as pull-down network. Because we have two inputs for NAND gate, y is equal to a dot b the whole bar. A dot b the whole bar means we have two inputs for NAND gate. We'll be using four transistors, four MOSFETs, two p-type MOSFETs and two n-type MOSFETs. P1, P2 are the two PMOS transistors. N1 and N2 are the two NMOS transistors which we are using. And the connections are as shown. The source terminal of P1 transistor is connected to VDD. Similarly, the source terminal of P2 transistor, P2 MOSFET is connected to VDD. Drain and drain of P1 and P2 is shorted and it is given as output. Drain of NMOS transistor N1 is connected to the output terminal, which in turn is connected to drain of P1 and drain of P2. The source of N1 is connected to drain of N2. The source of N2 is connected to ground. The gate of P1 is connected to gate of N1 and is given as input called as A. The gate of P2 is connected to gate of N2 and is given as input called as B. Whenever we are trying to draw the circuit diagram with respect to CMOS logic, for dot operation, we always implement PMOS transistors in parallel and NMOS transistor will be connected in series. So here we are performing dot operation. Y is equal to a dot b the whole bar. That is a Boolean logic for a Boolean expression for NAND gate. A dot b the whole bar. Because we are using dot operation, PMOS transistors are always connected in parallel and NMOS transistors are always connected in series. So using this circuit diagram, let us try to implement the same circuit diagram with respect to stick diagram form. The first thing which we do is we draw VDD and ground line, which is represented by metal, blue color. Next, we take p-type diffusion above the demarcation line and n-type diffusion below demarcation line. Because P1 and P2 are connected in parallel, the shape of this diffusion is taken this way. And because N1 and N2 are connected in series, the shape of n-type diffusion is in the form of a stick, a small stick. P1 transistor is formed when diffusion crosses polysilicon. Similarly, P2 transistor is formed when p-type diffusion is crossed with polysilicon. The same thing is done here. Whenever diffusion, p-type diffusion crosses polysilicon, we get P1 transistor. Whenever p-type diffusion is crossed with polysilicon, we get P2 transistor. Similarly, NMOS transistor is formed when n-type diffusion crosses polysilicon. So we have formed two NMOS transistors, N1 and N2. Let us now represent the terminals of P1, P2, N1 and N2 with respect to the circuit diagram. So however we have represented the terminals with respect to this circuit diagram, the same way we have represented in our stick diagram. Next, after this, we have to give connections. Gate terminal of P1 is connected to gate terminal of N1 and this in turn given as input called as A. The same thing is done. Gate terminal of P1 transistor is connected to gate terminal of N1 transistor and it is given as input called as A. Similarly, gate terminal of P2 transistors is connected to gate terminal of N2 transistors and is given as input called as B. Gate of N2 transistors is connected to gate of P2 transistor, P2 MOSFET, that is given as input called as B. Source of P1 is connected to VDD. Similarly, source of P2 is connected to VDD. Same thing we have done here. Source of PMOS transistor P1 is connected to VDD. Source of P2 is connected to VDD by making use of a metal layer. Next, similarly, drain of P1 is connected to drain of P2, which in turn is connected to drain of N1. And all these three drains, P1 drain, P2 drain, and N1 drain is given as output. The same thing is done here. Drain of P1 is connected to drain of P2, which in turn is connected to drain of N1, which is given as output. Next. The source terminal of N2 MOSFET is connected to ground. The source terminal is connected to ground by making use of a metal layer. After this, we have to establish contacts. Whenever there are electrical connection which has to be established between two different layers, we use contacts, or we also call it as VR, VIA, VR. Diffusion, P-type diffusion, metal layer, two different layers, so we have to establish a contact. Diffusion, metal, we have to establish a contact. N-type diffusion, metal, we have to establish a contact. Similarly, N-type diffusion and the metal region is connected, so we have to establish a contact. So this is how we represent a NAND gate using stick diagram. I hope that you have understood how to represent NAND gate using stick diagram. Thank you.